Hello, it's Agric today again on ARCN Television, Abuja, Nigeria. I am Khadija Oluwatoyin. Here we are at NABDA AATF, a pod borer resistant cowpea production research farm, where we have the BT cowpea being planted. As you can see, this particular farm is being dedicated for the BT cowpea, and we have somebody that will be joining us on this episode of the program to give us more enlightenment, just like we had Dr. Rose Gidado had done the theoretical explanation of how this research had been and what we should be expecting. Okay, like I said earlier, we have an expert. Is Dr. Charles. His Yoruba name is very, very long. Sir, welcome to the program.
Yes, thank you. Yes, my name is Oguremilo Ashijibomi Charles. I'm a plant breeder here in NABDA.
So Dr. Rose Gidada told us so many things about this particular pod borer resistant cowpea, and then for practical reasons, that's why I want you to explain to us further. What exactly? We've seen it. They said it's not been infested by some. It's resistant to some insects and the rest of it. Aside that, what other advantage does this cowpea has?
Yes. Well, to buttress what my director had already told you, this is the PBR cowpea farm. That is the pod borer resistant cowpea. Which has been developed against a particular insect called Maruca vitrata. There are other insects that invades the cowpea plantation, which is why we advocate for 1 to 2 sprays instead of the 5 to 8 sprays that has been done, that is being done by farmers. So this particular variety was developed in IAR Rosaria, that's the Institute for Agricultural Research, and what we are doing presently is to infer different spray regimes. Okay. We need to know the type of spray that best suits this plantation, and how many sprays, so that we will know what to tell the farmers. So this particular plantation is against Maruca, but there are other insects. So if you want me to brief you on what we are doing specifically, we have 3 treatments being done here. So treatment 1 goes for contact insecticide. Treatment 2 goes for contact and systemic insecticide for 2 sprays, while treatment 3 goes for contact and systemic spray for 3 sprays. So at the end of the day, we want to see the variation in the yield, so that we will be able to tell the farmers, oh, just 2 sprays of contact is okay, just 2 sprays of contact and systemic is okay. So the one that gives us the best yield will be the one that will postulate to the local farmers out there.
So is it that it's being divided? How do you now know which is which? I see that there are some labels and so what's the difference?
So on this side of the plots, okay, on my left hand side, apart from the treatments I talked about, we are doing different planting spaces. So for this part of the farm, we have 75 centimeters in between plots, in between ridges. Okay. While on the other side we have 60 centimeters, that's 0.6 meters in between ridges. That's ridges to ridges. So we want to see the best space that suits the plant. And aside that, the different plots which has been well labeled. Plot 1, plot 2, plot 3. So plot 1 is for contact insecticide, 2 sprays. Plot 2 is for contact and systemic insecticide, 2 sprays, while plot 3 is for contact and systemic but 3 sprays. So at the end of the day, we want to see which spray regime that will best suits this plantation, that will now be able to advise farmers rightly. So this is the aim of this cowpea production research farm.
So, if achieved, if the aim is being achieved, what does this portend to the Nigerian, in fact, let me say consumers?
Yes. At the end of the day, well, let me start with the farmers. They will spend less on insecticides, and you can see the pod filling, and the pod that is emerging from the farmers will be able to have more money in their pockets, and there will be enough grains for the consumers to feed on. So this will reduce the deficit of cowpea that is being experienced. So this will reduce the deficit of the imports of cowpea grains into the country. So and at the end of the day, we will be able to beat our chest that we are food security to a considerable extent when it comes to the cowpea.
Okay, looking at looking at how the cowpea is coming up. Can you tell us different? I can see some are green. I can see some are getting dried, and the rest of it. Can you show us?
Well, for now, we planted this on the 26th of May this year. So as you can see, if this is the second month,
Yes.
today makes it 2 months and a day that we planted this, and you can see that they are already getting matured. In fact, we are already planning to harvest the pods. So they are extra early varieties. They are
Okay.
extra early maturing varieties, and the reason why you are seeing some form of yellowing is because they are getting matured and they are ready for harvest. That is the reason why you are. But irrespective of that, we we are still experiencing, or we are still seeing flowering. They are still flowering, and we are still, even after the first harvest, we are still expected to do a second harvest and possibly a third harvest, as
Oh
we can
wow!
still see flowers
Not that
still
you're
coming
going
up.
to replant on this same
No,
particular.
on this same particular plantation, yes. So we expect to do up to three um,
Harvest.
regimes of harvesting.
With the explanation by Dr. Oluwashijibomi Charles, it no doubt that this cowpea, if has gotten to the last stage of testing, is going to go a long way in surfacing with the way food sufficiency is being mentioned by the federal government. Federal government has already said it has is planned to ensure that Nigerians have enough food to eat, irrespective of whatever it is that the economy is passing through.
The Bacillus thuringiensis gene, also known as the Beta gene, is a naturally occurring bacterium that produces a protein toxic to certain types of insects. The gene inside the bacterium responsible for producing the beta gene toxin can be transferred to crops, thereby making them resistant to corresponding insects.
Beta gene is a gene that enables an organism to protect itself against some group of insects. They are called lepidopteran insects. These are chewing insects, and is restricted to only those ones. So any plant that has this gene in it will be able to protect itself against this invasion of these insects.
In Nigeria, the beta gene has been used as a solution to problems of cowpea farming and that of cotton as well. For cowpea, the beta gene has been utilized for the crop's resistance to the maruca insect, also known as a pot borer, which preys upon the cowpea plant. And in cotton, the beta gene gives resistance to the crop against the pink bollworm.
You know, in every society, modification is the best. And when you modify your crops in terms of agriculture, it means that you are aiming for certain qualities and certain benefit. Part of it, when you modify it, is getting high yield, circumventing diseases that are affecting the crops, circumventing the insects that are devastating the crops. So all these have been the focus when we modify the cowpea and when we modify the cotton.
The integration of the beta gene into cowpea and cotton production in Nigeria stems from the gross damage incurred by farmers of the two crops for years. In the case of cowpea, the destruction caused by the Maruca's infestation of cowpea plant results not just in reduction of yields, but also the quality of harvest, as losses could be up to 80% in severe cases. For cotton, on the other hand, the infestation of the pink bollworm on cotton plantations has made farmers lose tons of harvest, making farming the commodity a nightmare for many. The use of conventional insecticides to control these pests are not only expensive, but their availability is limited. Farmers also lack proper skills in their usage, thereby posing safety challenges. This narrative began to change in 2018 with the National Committee on Naming, Registration and Release of Crop Materials, also known as the Varietal Release Committee's approval for the commercial release of two BT cotton varieties. The approval for the commercial release of the BT cowpea variety followed shortly in 2019.
Reduction in insecticide spray and then high yield. It gives you high yield because they are already protected from the insects, those insects. In the case of cotton is the pink bollworm. In the case of cowpea is the Maruca vitrata larva. Larva is a caterpillar. So at the caterpillar stage, that Maruca is the butterfly. The common name is butterfly that we know. And so the butterfly, when it gets to, that's during its developmental stage, when it gets to that caterpillar stage, it destroys the pods, the leaves of cowpea, and then, that is it. For the farmer may lose almost everything that he has actually cultivated. But thank God to this technology, thank God to that, the Bacillus thuringiensis gene that has actually given back life to farmers, giving them high yields, because once the plant is protected from what damages it, what causes losses and what, of course, once they are protected, that is it. You will have the normal yields that actually you should have, actually had access to. And so I can go on and on. For the cotton, it can actually help Nigeria to revive or revamp the textile industry that are already marrow-bound.
Not that the gene itself increases yield, but because it addresses a constraint, which is the insect attack. Now the yield is going to increase bountifully, and ultimately the essence is that the farmers can produce more and generate more income through the sales, and the consumers will have more to eat.
Since the commercial release approvals for the two commodities, there have been open field trials by farmers across the country. Farmers who have planted the BT cotton, for example, say it gives superior lint with good quality, high fiber strength, and much more cotton balls. A sharp deviation from what obtained with the conventional cotton varieties, which was characterized by stunted growth and high pest infestation. With the BT cotton, farmers now harvest up to 4 tons per hectare, compared with the old varieties, which yielded just 1 ton per hectare.
The experience, particularly in this 2021 wet season, of the BT cotton that we have planted has been, in fact, you can now see why the eagerness is there amongst our farmers. It's fantastic. Fantastic in the sense that we had, for instance, some areas where Unfortunately, we had some, the rain pattern, or rainfall rather, was not as expected, and then, of course, the break in rain. But we found that the cotton, because we enjoyed, at least we planted, germination rate almost 100%, and because, of course, moisture had gotten into it earlier on, and it had gained some strength, that they survived that period.
Cotton farmers who erstwhile abandoned planting the commodity for soybeans and sesame due to low yields are now embracing the crop once again and even considering expanding their farms.
We will roll out the seed to them. As an association, they expect and they are counting on us to be able to give them this BT cotton. Like I said, during the trial period, some farmers, of course, from our association participated. They saw the difference. In yield, like I tell you, on average, the farmer that sources his or her seed on their own are getting maybe 400, 500 kg per hectare. With this BT, your minimum is 2 metric tons. And if you are able to carry out and maintain your farm accordingly, following the best agricultural practices that we also try to impact on our farmers, we're talking almost close to 4 tons that you can make. And so the farmers know what that means. That extra kg, they know what it means in terms of value, in terms of the money that comes into their pocket.
On the part of the BT Cowpea, the farmers have never had it so good. The massive transformation seen with the new variety has them now spraying their crops just twice as opposed to the 8 times previously sprayed. And what's more, harvesting is done within a shorter period of time.
Having grown cowpea before now and seeing the challenges that we have with very low yields, and the challenges of the Maruca worm and having to spray continuously all through the season, I'm very excited to be growing the BT cowpea. It's so much easier to grow because we spray far less. And also, it's very, very apparent that the Maruca does not affect the BT cowpea. And so the pods are cleaner. We're getting a lot better yields. The yields are much higher.
The BT cowpea is definitely seen by the farmers as a game changer in Nigeria's cowpea cultivation, as the level of the commodity's growth, earlier maturation, pod sizes, and resistance to pests is simply amazing. The farmers say it can't be compared with other varieties, and the demand for the seeds by other farmers who have seen its yield performance and pest resistance is huge. The lockdown induced by COVID-19 and severe floods in agrarian states pushed down the country's food production. Cowpea was particularly badly hit and has seen a massive rise in costs owing to their decline. The massive cultivation of the BT cowpea is expected to hopefully help change this narrative and slash rising costs of beans.
If you are in Nigeria and you try to buy beans in the past year, you will see that the yield of the cost of beans has skyrocketed. And that's because a lot of farmers lost their crop last year, and it's because there was so much Maruca infestation. However, this year we planted the trials, and we have now planted also the commercials. It's in the market basically, and so we planted the seeds that we bought from the seed companies this year. It did excellently, and so of course now we can project, to be able to do commercial production of cowpea. And hopefully in the next few years, we'll see the prices of beans come down.
We cannot claim to be the giant if we cannot feed Africa. Even Africa is now looking upon us. And come the year 2050, when the population of the world will be almost 10 billion, there is no continent better placed than Africa to contribute to the global food security. And Nigeria being the giant in Africa, the contribution of Nigeria is going to be appreciated.
The BT cotton's output has shown Nigeria's cotton production
The Bacillus thuringiensis, or Bt gene, is a common soil bacterium around the world. The Bt bacteria and proteins have been used for several years as biological controls for certain insect pests in farming, particularly the organic food sector.
Well, Bacillus thuringiensis is a bacterium which has many beneficiary genes in them. Many of these genes are used, to produce certain proteins, the cryo, genes. Proteins which are kind of poisonous to many insects, and they help in protecting our plants against pest infestation. It is like a mystery, when you look at the Bacillus thuringiensis, in the sense that there are pluralities of genes in it, so that one protein may be harmful to a particular insect, but not to others. So there is selectivity in terms of that, such that there is the target insect and the non-target ones.
Bt is a bacteria living in the soil. It is called, in our jargon, scientific jargon, Bacillus thuringiensis. So this is where the B and T came from, Bacillus thuringiensis. If you go to any shop where pesticides are sold, you can find the bacterial spores, live bacteria is sold as a biopesticide. You can go and apply it in your crops if you got some worms which penetrate into the fruit or the stems. The bacteria itself is sold as a biopesticide since 1930s.
Some approved crops fortified with the Bt gene around the world include the Bt maize and the Bt cotton, which have been used and consumed in some developed nations and even South Africa.
The technology used for Bt cowpea is the same as the technology used for Bt maize that you mentioned is already being grown and consumed in South Africa, also being grown and consumed in many countries around the world in large quantities in that. And we have more than 2.5 decades of experience with crops such as Bt maize. So the same technology in Bt cowpea, it's been tested, it's shown to be safe. We also have the same technology in eggplant, Bt eggplant, which is being grown by farmers in Bangladesh and consumed. So there's a lot of experience with the technology and every reason to believe, of course, the product is safe. So there are no concerns.
The Bt gene has now been infused into the cowpea plant to fight the Maruca pod borer, an insect pest that preys upon cowpea plants in many African countries, including Nigeria. This follows previous research by scientists to stop Maruca infestation on cowpea plants, which were unsuccessful.
Some work by IITA in the late 90s and early 2000s, trying to get some conventional cowpea varieties from wild sources, which they cross to ensure that those varieties are having some level of resistance. But those varieties have not been successful. They could not protect the crop against the pod borer. So they are not successful with farmers because they don't have a good seed color and seed size, and the resistance is not durable. It has broken down. So we have to restore to this Bt using biotechnology to integrate some genes from non-related plant species. Because bacterium is a plant, cowpea is a plant, but we took this bacterium from this gene from bacteria to our crop cowpea. This is why it is very novel. It's a new work.
The Bt gene-enriched cowpea is also known as the Maruca-resistant cowpea and contains the Cry1AB and NPTLL genes.
A Bt gene is a gene that enables an organism to protect itself against some group of insects. They are called lepidopteran insects. These are chewing insects and is restricted to only those ones. So any plant that has this gene in it will be able to protect itself against this invasion of these insects as if it has been sprayed with an insecticide. And the origin of this gene came from olden days when farmers discovered that by fermenting soil, they will be able and decant the water from that fermentation process, and they spray it against their vegetable crops. The vegetable crops are effectively protected against insects that come and feed and destroy them. So scientists from that observed and discovered that there's a particular ingredient that allows or permits insecticidal effect which comes from the soil.
The Bacillus thuringiensis bacteria produces specialized proteins, also known as the Bt protein, which kills certain types of insects without affecting living organisms. This means it is safe for human and animal consumption. It has been extensively studied with regards to crop safety, with no concern so far identified.
From NABDA farm here at the airport road, we are going to be closing the program Agric today. Thank you for joining us. Don't forget to like our program, like, share and drop your comments on our YouTube page. I am Khadija Oluwatoyin, saying catch ya.